So the configuration on the layer 3 switch is really going to be just as follows. Now, keep in mind, some older routers will require the support for IPv4 routing to be hardware enabled. In order to do that, we will utilize a command, SDM, prefer LAN-based routing. We see that here. Okay, so that command turns on IPv4 routing capabilities, and then generally speaking, we have to reload the switch because it's a hardware-enabled thing. So you type reload. Once the switch comes back up, then you're going to have the IP routing command from global configuration mode that becomes available to you, and you type that command in to turn on the layer 3 functionality. The next command would be the interface command with a VLAN and an ID. All right, what that does is it creates those virtual VLAN interfaces for each VLAN that we require routing on. It's a little different than the router on a stick where we actually had to type in the number for the sub interface. Here we're just saying we want to create an interface for this particular VLAN. And then the switch handles creating that virtual interface. It will also take you into the SVI configuration mode, that interface configuration mode. And it's there that you would type in the IP address followed by an address and a subnet mask that's appropriate for that particular VLAN. Okay? No shutdown is an optional step. The interface should be up, but if it is not up, it's been turned off, administratively down, then we would issue the no shutdown command in order to turn the interface on. So when we use this option, when we use the layer 3 switch using switch virtual interfaces, the physical interface acts as a standard layer 2 interface just as they always have, okay, with the same switch logic. The SVIs are only used when a frame is received by the switch that happens to be destined to the MAC address of that switched virtual interface. Remember, the clients are configured with the IP address of the switch virtual interface as their default gateway. So when the client has a packet that's destined for another VLAN, just because of, they've done a DNS query and decided that was the case, then they send a packet to the switch, and the MAC address in the frame is for the virtual interface. So it gets routed there, and then that's when the layer 3 logic is happening. As an alternative to this configuration, a layer 3 switch can be configured to make a physical port act like a router interface instead of a switch interface. In order to do this, in doing so, it configures the port as what is called a routed port instead of a switch port. When a frame arrives on a routed port, the switch performs routing actions instead of layer 2 switching logic. Okay? So this is simple enough. It's just, do we want to use virtual interfaces or do we want to use physical interfaces? Now keep in mind, the routed port is only available in a specific configuration, and that's a configuration where the switch only has a single interface that's connected to the subnet. So in a lot of cases, this is not going to be available. If a switch has multiple interfaces that are access interfaces for clients on the same subnet, on the same VLAN, then you don't just turn one port per VLAN into a routed port. That's not really the idea here. It's for a different kind of scenario. So it's this kind of scenario where we have a layer 3 switch that's got two VLANs, VLAN 10 and VLAN 20. All right, and so we would basically be using SVIs for these VLANs. So I would have gone through the process of creating a virtual interface for VLAN 10 and it would be given this address. A virtual interface for VLAN 20 given this address. Then on the other side though, we've got an interface that's connected to a VLAN that's simply the layer 3 switch and maybe an edge router. Okay? So there's only one interface that's even connected to that VLAN. So there's never a reason for that interface to act as a switch port. Instead, that's the situation where we turn it into a routed port. Okay? So it's just, like I said at the beginning, it's important to understand where we would be using these configuration options. The router on a stick is used in a situation where we've got a small number of VLANs, and a separate switch and router. Okay, the layer 3 routing, everything but done internally, situation where we have a larger number of VLANs and we've upgraded to layer 3 switches, which most modern enterprises have at this point. And then this configuration, allows you to connect to a router using a single VLAN while other ports on the switch continue to support other VLANs. Now, the process for configuring a routed port is really simple. It's basically a single command. You go into interface configuration mode on the particular interface that you want to deal with, and you just run the no switch port command. Okay, switch port is the default, of course, because a switch treats all of its ports as switch ports, telling the switch to just perform layer 2 logic on those switches. But when you run that command, it automatically turns it into a routed port. Once done, that means you can configure an IP address and mask on the interface and treat it like a router interface. Before you had run that command, that option would not be available to you. Now, in order to verify it, you can use the show interfaces command. Show interfaces will list it as a routed port. Show interfaces status, same thing. Show IP route, it would include that interface as a potential route. And then show interfaces and the type number for the interface, followed by the switch port command, just by the sheer fact that it showed you very few details on that interface, would tell you that it was not, in fact, a switch port. Okay, so that's sort of a backwards way of doing it, but you can hit the interface and say, okay, show me the status, but show me the switch port status. And because it's no longer a switch port, it just doesn't show you much of anything. But different ways that you can verify it, verify that these ports have been turned into routed ports. So routed ports are used in a very particular scenario. They're typically used for point-to-point links between two devices that do routing, while SVIs are used for switches that have multiple ports that require routing between VLANs. Okay? So in actuality, even though we said you have a few different choices, when you start looking at the individual scenarios, most likely one configuration option is going to work best given a certain scenario. So typically access switches are going to use SVIs. Your distribution and core layer switches will often use router interfaces and function with layer 3 logic. And in some cases, engineers will configure multiple links between the core and distribution switches and then create layer 3 or L3 ether channels. Now, we've talked about ether channel before, but we discussed it in relationship to layer 2 ether channels. Layer 3 ether channels work the same way as layer 2, they just use layer 3 logic. So that means they now use routing protocols and routing logic. But it's the same concept. And so if you're using routed interfaces between your distribution and core switches, then it's a benefit to you to have multiple connections to those or between those switches, multiple routed interfaces. And so what you can do is you can go into global configuration mode and you can add the channel group number and then mode on command in order to add it to a channel. Okay, so sorry, we didn't have bold there. So channel group, the number, whatever number we want to specify, mode is on. That will be that's done on each individual interface. I think I said global configuration. That's an interface configuration mode once it's been turned into a routed port. Now, you do want to use the same number for all physical interfaces on the same switch, but you can have different numbers on different switches, albeit that it's easier just to keep it the same across the board. Okay. Add the no switch port command. That's required again because we've got because we're configuring that as an ether channel. Then we use interface port channel and the number to move to the port channel configuration mode. If you recall, we've actually created somewhat of a virtual interface that references these two physical interfaces. So it's actually called PO1. So we're creating that. We move into that configuration mode. We change the port channel into a routed port. And then once we've changed it into a routed port, we can issue the IP address command and assign an IP address and a subnet mask. All right, if you recall the layer 2 configuration, it was virtually identical with the exception of we didn't need to go in and configure IP addresses because it was layer 2, all right? So routing within the LAN is something that's going to be required in a lot of scenarios, and you do have different options depending on your situation. So as we finish up here, let's just summarize those once again. The router on a stick option using a trunking protocol and trunking port is used in scenarios where you've got a separate layer 2 switch and an edge router and a small number of VLANs that you need to route traffic between. All the traffic that needs to be routed flows across the trunk between the router and the switch. The layer 3 switching with switched virtual interfaces works well on access switches, allowing them to route between VLANs internally, utilizing a switch virtual interface that exists for each VLAN. And then the routed port typically is done, I know we saw a graphic of a separate VLAN connection between the switch and a router. That's one of the scenarios. The other scenario would be most commonly used with distribution and core switches, so that the core of the network is using layer 3 logic and routing protocols as opposed to layer 2 logic. So you want to evaluate each scenario that you're in, or you want to evaluate the scenario in the exam question to try to determine what the best approach would be. And then, of course, it's important to understand how to go about the process of configuring those.